In this problem, we have a cylindrical container, okay, somewhat like this. It looks like this. The cylindrical container is initially empty. There is nothing inside it. Let me also give you the dimension of the cylindrical container. So, the base of the cylindrical container, is circular, and the diameter of the base is, let's say, equal to D. Now, what is done is, inside the container, a ice cube, okay, is placed. Ice cube means an ice piece which is shaped in the form of a cube. The sides of the ice cube is, let's say, equal to L. So, it is placed inside the container and kept like this. Now, what would happen? The ice cube would slowly melt. The ice would melt into water. And where would the water go? The ice would melt, water would come, and it would start collecting inside the container slowly. Now, there is a piece of information that has been given that when the ice cube melts, it keeps its shape of this cube. Let me once again repeat. So, as the ice melts, it would turn into water. So, the volume of the ice cube would keep on decreasing, right? Because some portion of the ice is melting into water. But what I am saying is that as the ice cube melts, it remains a cube. But since some portion of the ice has melted, so the sides of the ice cube would reduce. So let's say from initial L length, at some point of time, the ice cube has melted to a length of L dash, then L dash would be less than L. Okay? Although this information is not given to you in the problem, but let me provide this explanation to you, that as the ice cube melts, it retains its cubical shape, but the sides of the ice cube would keep on reducing. So the ice cube melts, water starts collecting inside the container. Now you should be able to understand that the ice cube remains under water as it melts. Correct? Because the water is collecting inside the container, and hence the ice cube comes in contact with the water, and hence basically it's something like that the water would start producing a buoyant force onto the ice cube. Initially there was no buoyant force on the ice cube, but as the water collects, the ice cube becomes inside water and the water would provide a buoyant force. What the problem states is, number one, you have to find out, okay, what is the length of the sides of the ice cube. Let me write over here as cube. So you have to find out what is the length of the sides of the ice cube when the ice cube loses contact with the bottom surface. Let me write it down over here. When the ice loses contact with the bottom surface. I'm not explaining why the ice cube loses contact or how can you determine what is the point when the ice loses contact. That you have to evaluate, think about it. That is the physics of this problem. So you have to find out the length of the sides of the ice cube when it loses contact with the bottom surface. This is first part of the problem. The second part of the problem is similar, but the statement is a little different. So once again, let's say we have the same container, but initially it is not empty. Initially, let's say it is filled with some oil. Okay. The oil has a density of, let's say, rho O. Okay. And it is filled till a height of, let's say, Y, where Y is less than L. Okay. So these informations are given that initially the container is filled with oil up to a certain height. The density of oil is rho 0 and the height is Y. Y is given, of course, and Y is less than L. That is the length of the ice cube. Now what happens is the ice cube is placed and it starts melting. So water would form. Water does not mix with oil. Okay. So the water would start collecting somewhere. Now the density of water is rho W. The density of ice is rho I. And we know that rho oil is less than rho ice is less than rho W. This information is also given to you. So the ice melts. Once again, the water starts collecting. It doesn't mix with the oil. Okay. In the same situation, you have to find out what is the length of the sides of the ice cube when this ice cube loses contact with the bottom surface. Okay. So in the second part of the problem also, the ice cube melts in such a way that it retains its cubical shape, but of course the length of the sides keep on decreasing. So the problems in part 1 and part 2 are very similar, with the difference that initially in problem 1 the container was completely empty and the ice cube was placed, and in the second part of the problem the container had some amount of oil inside it, okay, up to a certain height, and the height till which the oil was kept is lower than the sides of the ice cube. Next, the ice cube is placed and it starts melting, and you have to find out the length of the sides of the ice cube when it loses contact with the bottom surface. Try these problems out. If you are not able to solve the problem, the solutions are coming up in the follow-up videos. Okay, so let's jump into the follow-up videos for the solutions. Thank you.